So for this example, we are going to determine whether a pair of lines in the same coordinate system are parallel or perpendicular. Now, if we graph two lines in a coordinate system, one of two things is going to happen. Either the lines are going to intersect each other, that means they're going to crisscross each other, or they're not. If they don't intersect, then the lines must be parallel to each other, and that means that they run side by side. So thus the equations of parallel lines will have the same slope, but different y-intercepts. If the lines do intersect each other, that can happen in one of two ways. They're either going to intersect at a 90-degree angle, or they're not. So to determine if the lines intersect at a 90-degree angle, that means that if we multiply their slopes together, it should equal -1. And the only way that the product of two values can equal -1 is if the values are opposites and inverses of each other. So therefore, if their slopes are opposite and inverses of each other, then the lines are perpendicular. So here we're going to determine if these three sets of lines here are parallel, perpendicular, or neither. They don't have to be parallel or perpendicular. And we're going to use the slope-intercept form in order to determine that. Remember, that's y is equal to mx plus b, because we could easily see the slope when it's in this type of format. So for the first set of lines here, we have the line y is equal to -6/5 x minus 3, and 10x minus 12y is equal to -42. So I'm just going to write them here. So we have y that's equal to -6/5 x minus 3, and we could see right here, here's the slope of this line, -6/5. But this particular line, 10x minus 12y, that's equal to -42, that's in standard form. So we're going to write this in slope-intercept form and then compare their slopes. So the first thing we can do is we will subtract out the 10x. So we'll subtract 10x from either side. That'll give us -12y. That's equal to -10x minus 42. We can then go ahead and multiply either side by -1/12, or like I like to do, we'll just do the whole thing. So we'll multiply by -1/12. And of course, we distribute this to each term inside the parentheses here. So -1/12 times -12y, that's going to leave us with y. -1/12 times -10x, that's positive 10/12 x. And -1/12 times -42, that's positive 42/12. Now everything should be written in their simplest terms. So 10/12 x, that simplifies to 5/6 x, and 42/12 is 7/2. So as we can see here, the equation of this line right here, y is equal to -6/5 x minus 3, the slope is -6/5. And then 10x minus 12y is equal to -42. In slope-intercept, it's y is equal to 5/6x plus 7/2. Its slope is 5/6. So we can see that these slopes are opposite. An opposite means if it's negative, it's positive, or if it's positive, it's negative. And the inverse, 6/5, the inverse of 6/5 is 5/6. So if we multiply these two slopes together, our result will be -1. So since that's the case, then these two lines, y is equal to -6/5 x minus 3 and 10x minus 12y is equal to -42, are perpendicular to each other. I'm just going to write it down right here. So let's try letter B. So we have for x, that's equal to 90 plus 10y. That's this right here, this linear equation right here. And the other one we have as 10 is equal to x minus 5/2 y. Of course, that's this linear equation right here. So to write this in slope-intercept form, I could subtract out 90 from either side. This eventually becomes 10y. That's going to be equal to 4x minus 90. I can then either multiply both sides by 1/10 or the whole thing by 1/10. 1/10 times 10y, that leaves us with y. 1/10 times 4x, that's 4/10 x. And 1/10 times negative 90, that's negative 90/10. So this winds up being y is equal to 2/5 x minus 9. We'll do the same thing for over here. I'll subtract x. That'll give us negative 5/2 y. That's going to be equal to negative x plus 10. We could then multiply both sides or the entire thing by 2/5, negative 2/5. Negative 2/5 times negative 5/2, they'll cancel each other. That'll leave us with y. Negative 2/5 times negative 1x, or negative x, that's positive 2/5 x. And negative 2/5 times 10, that's negative 20/5. So this winds up being y is equal to 2/5 x. And 20/5 is 4, so minus 4. So as we can see, the slope of 4x is equal to 90 plus 10y is 2/5. And the slope for 10 is equal to x minus 5/2 y is also 2/5. And they have different y-intercepts. This has negative 9 and this one has negative 4. So since their slopes are the same and their intercepts are different, then these lines are parallel. So let's try C. We have 2x minus 3y. That's equal to 8. And the other line is 3y. That's equal to 17 minus 3x. To get this into slope-intercept form, I'll subtract out 2x. We then have negative 3y. That's equal to negative 2x plus 8. We can then multiply either side or the whole thing by negative 1/3. Negative 1/3 times negative 3y leaves us with y. Negative 1/3 times negative 2x, that's positive 2/3 x. And negative 1/3 times 8, that's negative 8/3. For this side here, I'm just going to rewrite this as 3y is equal to negative 3x plus 17. I'm just going to flip-flop those terms. And again, either multiply both sides or the entire thing by 1/3. 1/3 times 3y, that leaves us with y. 1/3 times negative 3x, that leaves us with negative x. And 1/3 times 17, that is 17/3. So here we have a slope of 2/3. And here we have a slope of negative 1. So these slopes are not opposite and inverses of each other, or they're not the same. So that means that these two lines, 2x minus 3y is equal to 8, and 3y is equal to 17 minus 3x is neither parallel or perpendicular. So I'm just going to put down neither. And I think we have it. There you go.